So how do we scale? Basically, we're going to look at the way SharePoint scales out. I've got two brief slides, which are pretty much marketing slides. The search technology concepts we talked about right at the beginning of the previous session. So can you just ask, was everybody here the last session? Who was not? One guy. Can someone brief him? So you ought to have seen this slide. Well, basically, this is top to bottom of the search engine. And I'm going to apologize, I'm going to have to go a bit quick because I've started late. Basically, search center, query servers, indexing, crawling, content sources. The bits we're most interested in this session are this guy, the query servers, and a little bit in the middle, the query processor. So basically the bits in the last three items on that slide there. And this is the marketing slide I mentioned. So we're talking about designing for size. This is at the capacity planning guide, and it's literally trying to just get the message over. I won't read it out, but the idea is to get the message over. How many servers do we think we need? How big can SharePoint search engines get? Anybody got one in this range? Greater than 40, 50 million objects? What about 20 to 40? Cool. This is very, very doable, even in a single search service application in SharePoint. We've got several running that are way bigger than that. And basically, it's kind of the idea is to get the message about when I've got so much content, do I need additional crawlers? Should I have an extra query DB, extra property DB? The majority of the data is driven by the capacity planning guide, which basically says, if I've got more than 25 million objects, I need another crawl DB. If I've got more than 50 million objects, I need another property DB. And by and large, up to and even over those values, so the classic one is the crawl DB, 25 million objects per crawl DB. You can only crawl a single web app via one crawl DB. So that immediately restricts a web application to 25 million objects. So just be aware of that one. That's not a hard limit, and we've crawled certainly way, way bigger than that. But you're effectively breaking the search capacity planning boundaries by having a web app with more than 25 million objects on it. Just something to think about. In terms of performance then, so to improve things like crawl time and result freshness, we're going to add more crawl servers. To improve search result latency, the parameter I mentioned previously about the security descriptors is great, but it only goes so far. You might find that actually your performance bottlenecks are on your disk. So the search engine has to make full text queries to a disk. It has to make property queries to a SQL database. So by expanding those out, you'll equally get performance benefits. And then from a search results availability perspective, adding additional query servers, mirrored components, failover components, they all add to the search experience and make things, improve the capabilities of the product in terms of how many queries per second can I get through, and more availability in terms of what happens if my crawlers fail over, what happens if my query partitions fail over, or fall over. So having seen that, the first thing I'm going to do here is, for those of you, one accepted, who saw the search service application earlier, I'm going to get some PowerShell going, which is going to take the search service application that we had, and I'm going to blow it out. And I'm going to walk you through the PowerShell, and then while it's running in the background, we'll do some more slides. And hopefully, everything's going to be great. I don't want to do that, because it ain't going to work. When I get the thing loaded, I'll... is it already there? Is it already there? It's already here. Okay, so I'm going to dump all the messaging. So basically, the first part of this is going to have the snap in, which Spencer's already done, or Barry's already done. So basically, what we're going to do at this point is we're going to take our search topology, which I'll briefly show you again, which was this topology down here. So we've got two crawl components, one on SPO3, one on SPO4. We've got one crawl DB, so a single crawl store. Single crawl stores gives us headaches because we have a single crawl queue, so it makes scheduling difficult. And we have, well, four query components, but only two partitions. So if this was an index of more than 20 million objects, we're immediately breaking the capacity planning guidelines. As it is, we've only got 800 items, so we're not in a problem. But basically, we can see here we have, within the search property store, so associated to the property database, we have index partition 0, index partition 1, each of the partitions has 2 components associated to it, which basically means we have 2 active components. So both of those, in this case query component 0 and query component 2, is capable of delivering results for index partition 0. So they can, and we're going to talk about the round robin process in a few minutes. And then for index partition 1, we can do the same idea. We're going to blow this out. We're going to add 2 more crawl components. We're going to add another crawl DB. We're going to add another property DB. And we're going to drop 2 more index partitions on here, just as a simple scale-out exercise. From a crawl DB crawl perspective, and this is where I mentioned earlier that things might go spectacularly wrong. I might break everybody's job. Okay, I didn't want to add that again. So you can see here, is that readable? Is it readable at the back? I'm getting yeses and nos. Yes? Okay. So search service application, we basically get a handle on it. Here's the data about it. We know what it is. We can see some information about the topology of it. If you want to make this a bit bigger. Sorry. We can see in here, we can see our query topology, we can see our crawl topology, we can see our crawl stores, search admin DB, etc. And within the search service application, what you have is a scenario which is very, very different from any other service application. With all the other service applications, you can just connect them with PowerShell, make changes, update, and away you go, you're done. In search, you can't do that. The only way to modify the search service application is to create new, effectively what we call clone topologies of the existing application, configure them how you want them to be configured, and then activate them. When you activate them, it instantiates, well, several timer jobs actually, which have an action which basically say, take the old one down and bring the new one up, but it does it in such a way that there's no loss of service functionality. So it's very different, it's very invasive. If you've got multiple index partitions spread across multiple machines, you've got lots of file copy operations going on. You've got database moves going on in some cases as well, depending on how complex you make the change. This one's going to be relatively simple, just so we make sure we don't break anything. So what we have to do is, the first thing I'm going to do is get a handle on the active topology. So this is basically saying, what's the topology that we already know about? And I want that because afterwards I'm going to get rid of it. I want to delete it. So I just want to make sure I've got a copy of what its GUID is so I can get some details about it. I then create a new crawl topology. So with the query topology, it's slightly different. You clone the query topology. With the crawl topology, you create a new one. So we're going to basically say, the crawl topology that we know about already, those 2 crawlers sat on one on each machine, we're going to create a new one. We don't want that one anymore. We're going to build a brand new one. So I'm going to first of all check the original crawl DB, because all my crawlers have to be associated to a database. And I know the first crawl DB is there. I'm quite happy with it. It's online, it's available, so I'm just going to make use of it. But what I want to do is actually create a second one. So I'm going to add a second one to the mix, which is basically saying, give me a new crawl DB, and if I look in SQL now, we'll see that crawl DB is there and available to use. I'm not doing anything special. I'm just putting everything onto the default location, so it's going to go straight onto the default SQL location. Although in reality, you would move that to somewhere else as best practice. These lines are commented out for a reason, simply because I've decided to use the existing crawl DB, so I don't need to go and modify which components are connected to that database, because we already know the 2 we have are connected to it already, so I don't need to change those. I left that in the script just for information. I want to create a new crawl component now. So on my new database, I want to add a crawl component located as part of the crawl topology, connected to crawl database 1, which we saw already we had a handle on before, connected to search service instance 0, which is the search service instance here, which is basically saying, get me the search service instance on that particular server. So that's the server I want to add the crawl component to, so I need to get a handle on that search service instance. And then finally, where do I want to put the index files? Well, I'm just going to go for the default location, so C/program files / office servers, etc. And obviously you could specify different paths if you wished. So I'm going to execute that one. And everything's working so far. And then I want to create a second component, but this time again connected to the second crawl database, but this time on a different crawl server. So it's exactly the same process. We're just connecting to SPO4 instead of SPO3. and that gone, and that's done. So the next thing to do, quite simply, is to activate that topology. So this will perform the action of activating the new one, deactivating the old one, and then associating all the components as we've decided to configure them. That'll take a few minutes to complete that action. So what I'm going to do is I'm going to drop to the slides for a few minutes and we'll come back to this and carry on. And if anyone wants these scripts, they're not the most complex scripts. Typically you'd build loops and clauses and error checking in there as well, but this was just for the sake of demonstration. So things we just talked about, crawler. Let's look at the slides. And so we're going to scale out and deal with, how do we deal with failure and recovery? So crawling scale out, remember this guy from before? Very simple, one crawler, one crawl DB. The 2007 model, basically. Our single point of failure, single index, big problem in 2007. Simple scale out, and this is what we had in the search service application before I started working on it. We had 2 crawl components, so each one on a different machine, connected to a single crawl DB. So it gives us some component level high availability. If one crawler fails, the other one carries on. And it gives us some physical high availability. If we lose the entire server, we're not in trouble because we carry on. It was the biggest asking from SharePoint 2007. It's what everybody wanted. But we can go even more than that. We can take it to the next level, which is what we're doing now. This is what I've just basically done. So I've basically just turned this into this, assuming there's no errors. 2 crawlers on one machine, 2 crawlers on another machine, and cross-match to different databases. So the reason for doing this is because later I can look at something called host distribution rules, and I can assign different URLs to different databases. So I can give myself high availability, cross-component, cross-physical machine, and cross-database. So I'm able to have a really, really high availability, highly available, and highly distributed infrastructure. And we don't need to stop there. The number of crawlers you can have in the architecture is much, much more than that if you wish. 2 or 3 associated with a single crawl DB is about the limit you should be thinking about. Otherwise, you need some seriously highly performant SQL infrastructure under the hood. The crawl DB is, I think, the second most resource-intensive database in the whole of your SharePoint farm. The biggest one being the usage DB. How did the thing actually fail over then? So when we're actually in a process of we're crawling away, everything's quite happy, there's no problems with the farm, and then all of a sudden one of the machine blows up. What happens? Well, the crawl components, they perform a task. When they're crawling, what they're also doing is constantly checking in. They're constantly writing to SQL to say, yes, I'm still alive. I'm still here, I'm doing work, this is what I'm doing, I'm performing a job. The master crawl component, which we mentioned earlier, is basically the kind of the head guy, the slave driver, if you like. And he's basically saying, are you still here? He's checking in to make sure those crawlers are updating. If they're not, and they don't update for over 60 minutes, we put the crawl component into what's called recovery mode, which basically means take it offline. We set it and remove it from the topology. Sometimes it works, sometimes it doesn't. Sometimes you might see you've got your farm running, a crawler will go offline, and it'll sit there for days before it comes back online. If you're in that scenario, check your event log. You're probably seeing event ID 6398, which is the search service application administration timer jobs failed to run. If that's failing to run in your environment, this will not work because you need that service to run to be able to actually make this actually happen. If it does, say it all happens quite successfully, the first thing the master crawler will then do is say, right, okay, so I've got a crawl DB. It's got 2 components associated to it. One of them's failed. The other one's idle because it's finished doing its piece of work. So what do? I'll just assign all the URLs that that previous crawl component had or should have been dealing with to that component. So it makes sure, again, we have this high availability approach that losing a component doesn't break the indexing schedule. We won't lose anything. We should never miss even a single URL. Single item in the index should not be lost. And the rules-based, kind of a random, well, not random, but it's random if it doesn't know. If it knows it's got an idle component already, it will choose the idle one. And basically, if all components are currently still crawling, it'll just say, you know, component X, you take over where component Y is broken. If the master crawler fails, slightly different scenario, now you've got all the workers and no slave driver, so the workers then decide to, one of them, whoever checks the slave driver first, goes and picks the whip up and decides he's going to be the new slave driver and starts whipping all the crawlers, and he makes himself the new master. So it's a very, very simple operation. Slave driver's gone, I'm going to be the slave driver. And then he starts checking on everybody else. So how does it fail? So what if how does it recover? If the crawler fails, then there's a process that takes place. I already mentioned how the service application recovers by reassigning the URL somewhere else, but how does the crawler itself actually recover? So what happens when the component's repaired and restored to the farm, so assuming your administration jobs are running fine, maybe you reboot the server and it comes back up, the component's up, or you fix it, recycle low search, for example, then what will happen is the service will come online, but it won't necessarily start to crawl straight away. The reason being, there's the potential that that crawler might still have an association with the URLs that have now been passed to somewhere else. So the system, it's basically the crawler's halted. It's not allowed to start crawling again. If after 60 minutes it's still available online, then it can start crawling again. Now 60 minutes is a relatively long time in a crawl, especially if you've not got a very large environment. So what you can do is you can modify this registry key, the disable interval, and reduce it to something like 10 or 15 minutes. What you don't want to do is reduce it to a minute, because they only check in every minute, and you'll find your crawlers going offline like yo-yos if you start doing this with setting it too low. If you've only got one crawl component, of course, the URLs haven't been reassigned anywhere, so it just picks up and carries on. So that crawl queue is just processed by that component. The other thing to know, if the component that failed was the master previously, it is not the master when it comes back online. You know, you don't get the old NT-style browser election taking place across your network while they try and work out who's going to be the master. It simply kicks in again, and it's a regular crawler. The other thing to note, all crawl components must complete the crawl. So if you start a crawl off with 4 components and you finish it with 3 and a broken one, the crawl will never stop. That last server has to be either removed from the topology or else it has to be recovered. If it doesn't recover, your crawl will never ever stop. So don't think I've got a broken crawler, I'll wait till my crawl finishes before I fix it. What you do is you wait till your crawl rate drops to 0, so you've stopped crawling, but the server's still sat there waiting for this last crawler to say, I've finished, and then you recover it manually. From a query perspective, it's slightly different. I'm going to go back to my PowerShell, and we finish that off, and look at the query side. So the last thing we did was activate the service. And if I look at the topologies now, I'm just going to compare the current crawl topology with the initial one. And we should see the current one is now active. The initial one is now inactive. Okay, so that's fine. So I don't want to put that delay in. I'm just going to go and delete it. Yeah. So my first demo of the day that's gone swimmingly well. And if I look at the crawl topology, I don't want to do that. If I look at the initial crawl topology now, it should throw an error. Well, you can see there's no components in it. It's nothing. It's just basically sat there. When the timer job kicks in, that'll clean up. So that's the kind of the crawl side. If we go and look at the search service application, assuming it was actually successful, we should now see no changes. Great. Swine. Okay, my crawl components haven't kicked in. My crawl DB did. Okay, I'll come back to that one. That should have worked successfully. I'm a little bit alarmed that it didn't, because it worked fine literally 2 hours ago. I'll move on to query, but effectively what we should be seeing here is under this crawl store here, crawl store 2, crawl store 1, we should be able to see the original crawl store with the original crawl components still associated with it. We should have 4. Okay, so something's gone wrong in the PowerShell, but I don't know why. That should work fine. I'll come back and look at that if we get time. If we have a look at the query side, come on. Open the right file, Neil. There we go. So on the query side, kind of the same idea. Hopefully this one will be successful. At least it didn't break anything. We want to do the same idea. We'll load the search service application, check the initial query topology. So what do we have currently in that topology? And then we're going to do a new one again. So we're going to move from being 2 partitions to go into 4 partitions. So we're going to build a completely new one. So let's go make a start. I'll just make that up there. So there's our service application again. See our crawl topology, crawl stores, search admin, DB, etc., and property stores and query topologies that we had. We're going to grab the initial one, same as we did last time, same process, and then we're going to create a brand new one in this case. So that's created the new one. And then the next thing to do once we've created it is then to add in all the various, or get handle on all the various partition objects, so we can know what we're going to do with them. So very straightforwardly, partition 0, if I just run that, just to show you what the partition looks like when it launches, we can see very simple, it's got an ID, but it's got nothing associated with it right now. It's basically an empty partition. Doesn't know what crawl component it's going to belong to, doesn't know what server it's going to sit on, doesn't know anything like that. So I'll just run the same for the others. So we've got our 4 empty components. And then we actually want to get the service instance of the 4 machines that we're going to put these services, these actual partitions to physically reside on. So I run those. So we're there again. We've got our search service instances. You can see the instance, the server that's residing on, what its name is, etc. And just for argument's sake, I'm going to make sure that the service is actually running on those. And we saw the error message saying it's already started on 3 and 4, which we knew about because we'd been working with that one already, but we didn't get an error message for 5 and 6 because it wasn't running there. Now it is. And then the next bit is this kind of rather complicated approach where we basically take the new query component in the new topology, we assign it to an index partition, we assign the index partition to a search service instance, and then we provide the index location as well. So basically we're saying on the 4 servers that we have, create this component associated to this partition on this machine. And we do them across all the machines, so it takes a little while to run. So I'll just run them all individually, or sorry, all together. Fingers crossed. So we're good. This false here is fine. That's basically telling me that is it failover only, and they're not failover. This uninitialized is because we still haven't decided to activate the topology yet. And just to be on the safe side, we can see the components and they're inactive. We can see all of the other bits and pieces in terms of uninitialized, basically telling me that I've built this query topology, but it's not active, it isn't actually doing anything. So I want to use the existing property DB simply because we've had a search application running, we've done some crawling already, so we've got properties in that database. If I go and blow away that database, I'm going to lose all those properties and have to full crawl everything again. I might want to full crawl anyway, just because I've changed the topology, but in theory, and actually in practice, you shouldn't really have to, simply because something we're going to talk about, which is the index repartitioning process, where it will actually take properties and take content off the on-disk indexes and push them across to all the new partitions that we've created, effectively refactoring the index. So I'll just execute that through anyway, and that should go fine. So that's basically creating me a new property DB down here, so it'll take a few seconds. There we go. And then I'm assigning the partitions to the original property DB. So basically, remember I created 4 partitions, so I need to go and say two of the new ones I created assign back to the original database. So I'm doing partition 0, partition 2, and partition 0, and then partition 1 and partition 3. I'm going to assign them to the new property database. And then we can have a look at the query topology. And we see now we've got a query topology now, which before showed all empty in here. Now we can see we've got partitions and we have components. And then the last thing we need to do is the bit where everything can go wrong, is to activate it. So I'll activate it and then go back to the slides. That will take a little while. There's a lot of moving parts going on there, which we're going to talk about now. So in terms of scaling out query then, again, here's our Elvis Presley dude, comes along to do his query. This is how the query process actually works, high level. He issues his query into the SharePoint server. SharePoint server, via interrogation of the topology service and the search service proxy, knows where all of the endpoints are. So it knows where all the query components are. It knows where the query processes are. and it issues a request to one of the query processors via round robin. The query processor knows where the query components are, so it makes a request to one component from each partition. So partition 1 and partition 2. The next time he issues a query, same thing happens. Because of the round robin, it goes to the other query processor this time, and so on and so forth. It then hits the same partitions because it's a different query processor. So it's effectively we think about the first query and the second query. And then if he goes and does a third one, it might go to this first query processor again, which then goes to different partitions. So it's kind of a constant round robin approach. So this is assuming you've only got one user, of course. Every query processor will probably be dealing with, well, tens of queries a second or minute. And then you can see kind of how it breaks out in terms of the high availability side of things. You know, so any user hitting any SharePoint server, you obviously have a load balance set at the front, can make a request that can hit any query processor, that can hit any query partition. So by losing, you know, we could afford to lose 1M and 2 and the query processor, and everything would still continue to function quite normally. There'd be no loss of search, maybe a slight loss in performance, but no loss of search results availability. In terms of Scaleout then, so we can go from our default build, which is the 2007 typical model, with a single index partition and a single property store. So in 2007 speak, that would be our search DB. And then we've got our single partition, which would be our query servers. And then we can scale it out to 2 partitions, again on 2 physical machines in this case. We can go even bigger, so we can start to spread loads. Everyone see the TechNet documents and the big posters for search Scaleout? You've seen all the big things, so it's the same kind of idea. In this, we're spreading partition 1's on server 1 and 2, partition 3's on 2 and 4, 4's on 4 and 1, so we've got this kind of constant high availability of the partitions. So loss of one single machine will not result in losing the search index at all. And then we can go way, way bigger than that. In this case, we've gone to 6 partitions, so theoretically we've breached the 60 million object limit, and we've breached the 50 million object limit for a property DB, so we need a second property database at this point. So we're just scaling out, scaling out, scaling out. When query components actually fail, so the query processor, you saw in the kind of the high availability or the round robin diagram, the query processor knows where all of the index partitions are. It knows which service and where all the endpoints are listening. So basically, if one of them becomes unavailable, the service will know that, okay, my first partition for partition number 1, or my first copy of that partition has failed. I have a mirror, so I'll send the request to the mirror instead. So it's able to do that, and it's able to do that in flight. In theory, you shouldn't see an error. If the component reports an error back to the query processor, or doesn't report in at all, the query processor should go to the second server instantly, without you seeing an exception and having to resubmit your query. In practice, it's a bit hit and miss, but it's pretty good. Question? Yeah. Well, so the question was if you lose a drive where an index partition is located, as long as you've got another one, you shouldn't lose the service. So if you go back to this, for example, if the disk that this partition was on failed, and you lost that partition completely, the request would just go to this one. In practice, it's a tiny bit hit and miss. Depends how quick the execution takes place. It also depends on whether you've configured your query partition to be a failover partition only or an active mirror. So if it's a failover, then the query will not go first time, it will go second time. The first one will activate the partition. The second one will issue the result. The reason for having, for those of you who don't know, you can have failover components as well, which don't take part in the query at all. They receive updates. So for example, if we had a third component in here, or a third partition for query 2, which was failover only, if query 2 and query 2M failed, then the third one, the failover one would come alive. But it does take a few seconds for that to actually happen. So you would see a slight interruption at that point. But if your partitions are active, you shouldn't see any interruption at all. I do say shouldn't, but in practice, maybe 95% of the time. So the other thing about the failover then, if no active or failover component is available, so if you completely lose 2, partition 2 is gone in its entirety, there's debate over what actually happens. In practice, you should see no results. In theory, it depends how you lose the partition. If you lost all the disks for these 2 servers and partition 2 was completely unavailable, you will get no results. You don't get a partial set. You get nothing. In beta 2010, you used to get a nice little yellow bar that said, we're delivering you a partial result set. But they took that out. That's just, now you get nothing. If you corrupted the index on those files, so the files were still there, say there's this folder called CI files that contains all of the index files on the disk. If those files suddenly disappeared, or that CI files folder disappeared, but the disk was still there, SharePoint would actually be quite clever and build a ghost set of indexes. Completely empty, which means you would get no results back from them, but the query would still be successful. So you would lose all those hits, but you wouldn't know it. And you can test this, go away, just delete, take search offline, rename the folder, turn search back online, and SharePoint will build you a new set. Completely empty, but it means search continues. It's another high availability point. And then, basically, just what I was talking about, this ghost set to avoid destabilizing the index. So this folder, this folder here, I did that yesterday, the CI files folder, if you go away and just, or even, in fact, at any level in that architecture, if you go all the way up to the application level here, if you take that folder there, take netstop ms search exe, netstop o search, sorry, rename this .old, restart search, search will build you a completely new set of files, all empty, but all able just to say, no, I have no results, but I'm not going to throw you an exception. I'm going to keep working. How does it work in practice? So who's got SharePoint 2010 search environment? Everybody. Who's got 2 mirrors, or one query partition and 1 mirror? Who's got 3? Nobody. Okay. You all have a problem, right? So do I up here. The way the query components will fail or recover automatically is based on the number of them that you have. So if you look at the first line, let's say we're crawling along and we lose component 1, so query component 1 fails. Query component 2 is fine, it's online, that can still serve requests, but what will happen is the crawl will actually stop. The crawl will stop simply because, as we know, the indexer these days doesn't retain a local copy of the index, not for a appreciable amount of time anyway. So it queues up to a certain size, 8 times 250 megabytes, and then it stops. At that point, your crawlers are dead in the water until you, the admin, goes along and forcibly decides to dismount component 1. That leaves you with a single point of failure on your search index. So you have to make the conscious decision to put yourself in that state. The product group decided that that was not going to be something they wanted to be responsible for. We are not going to force the product to put you in a single point of failure state. You have to make that decision yourself. If you have 3 components, on the other hand, so you've got 3 query partitions now, and one of them could be failover, it doesn't have to be active, and you lose one of them, that's fine, the product will fix that for you. Because it knows if it dismounts this component, these 2 are still alive, you have high availability, therefore we're good with that, we'll take one out and refix it for you. So if you only have two mirrors, if you like, one active, one both active, you run the risk of this scenario. In all of the farms I've ever worked in, and it's a lot of big farms, that has never happened to me. So you don't really have a problem. You shouldn't ever get in that state. But if you did, and a query server goes offline, and it sits there saying offline, unless the product can bring it online with like a search recycle, search recycle, it will not dismount the component. It will not leave your query topology in a state such that you only are acting on a single point of failure. So that's a conscious decision, and that's undocumented. So as far as I know, I've not found that in any docs. So you must always have 2 responding components to initiate auto recovery. So don't sit there thinking the search engine is going to fix itself for you, because it actually won't. Index partitioning refactoring. So I'm going to cover this now before I go back to the PowerShell. It has finished, hopefully. Simply because this is what we've just done as well. So one of the things we just did was something called full text index partitioning. When we're crawling, our crawl components down here, crawler 1, crawler 2, 3 and 4 as we should have had, are basically pushing content to all the partitions. So any single crawler can communicate to all partitions. Even though we can separate crawlers to crawl DBs and partitions to property DBs, we never get into a scenario where we can actually say, oh, this crawler is only going to talk to these partitions. That's a kind of an impossible operation to have. The way it decides where to push content is based on this equation. So the remainder of the division between the doc ID, so every time you crawl content in SharePoint, every object it detects gets given a unique ID, not a GUID, but just a incremental ID, incrementing ID. Substitute the doc ID into that equation, you'll find out which partition your document's gone to. Okay, so useful for troubleshooting, not much use for anything else. And then the other thing about repartitioning, so every time you activate a topology, so we've just done this, we've just activated a topology. All of the changes that we wanted to do, so we wanted to take two index partitions, turn it into 4, so they're all spread out. And the way it does it, basically it takes all the data in those files, it does the calculation based on that equation there. Instead of substituting in 2, it does 4, and then recalculates where all the documents should be and pushes them all around. And the way it does that is through this process here, which I'll show you in a graphic in a moment, and it's the real reason why in the capacity planning guides for search, we say you need 4 times the disk space on your query servers to times the size of the index or index partition you're going to host. The reason being is this. So let's say we start our scenario, we have 2 index partitions, and we've decided we want to go to 3. So what happens? Well, on the same set of disks, we create our next component. We push them down. So here's our 3. We basically break it into chunks based on that equation. We know where the documents need to go. So at this point, we've got 2 complete copies of the index on the same set of disks. We then copy those to the new location. Chances are, this new location is in the same set of disks as the old location. We're just refactoring. Might not be, but usually is. So now we're into 3 copies. Then we do what's called a master merge. And the master merge means basically defragment this and make it contiguous. So we create yet another copy. So when we get to this point, we've actually got 4 copies on disk of the complete index. That's why you need 4 times the amount of disk space. If you're ever going to get into refactoring, make sure you've got the disk space. Refactoring without the disk space takes your search application down because it won't stop you from doing it. You'll just find yourself in a pretty bad state. And then the other thing, with the last demo I'm going to look at in a minute, is something called host distribution rules, where basically we can allocate start addresses to particular crawl databases. This also then does a refactoring process. So I can say, okay, intranet.isclondon.local, and assign it to a specific crawl DB. That means that the crawl queue in that DB, the crawl queue I mentioned earlier, that single host name will only ever be crawled through that crawl DB and dedicated to that crawl DB almost. The rest of it will go to the other DB. So we can start to split up which crawl databases are responsible for crawling which content. So if I'm crawling a really slow host, really slow website, for example, on the other side of the planet, I can say, well, here's a crawl component, here's a crawl database, you're responsible for a really slow crawl over that content. Use SharePoint content over here, your maybe BCS or maybe file share, for example. Whatever you want to do, I'm going to have another crawl component and another DB for you, and so on and so forth. And you can really kind of then build separate schedules, and instead of having all of your content queuing up in a big crawl queue behind a really slow request, you can basically push the slow requests elsewhere and just keep your nice fast request for SharePoint in a separate set of databases. It basically allows flexible scheduling. I say reduces costs simply because if any of you out there have ever bought an iFilter for something like a very expensive storage archive and you want to index it with SharePoint, you usually need some very custom connectors and custom iFilters that tend to be very expensive. If you go down the host distribution rule route, you can take a single machine, assign a crawl component to it, assign a crawl database to it, and only need the iFilter and the very connectors for that one machine. You don't need to distribute it across all of your crawl servers. So you've gone from needing 2 or 3 licenses to now needing just 1. And it's a supported way to truncate your crawl tables. Crawl databases get very big. We mentioned earlier about the crawl log getting very large. The crawl databases will get huge with crawl history, and there's lots of statistical data that's captured in there, lots of error data is captured in there. If you go down the host distribution rule route and reassign content across different databases, when it takes the content from one to another, so if you move my sites, and say you've got my sites and intranet in one crawl DB, and you want to say, okay, I'll take my sites over to another one. When it takes the my sites to another one, it brings all the data associated to my sites with it, but it deletes the rubbish it doesn't need. So it'll actually, in a supported way, truncate or shrink down your crawl DBs without any SQL intervention. And I think, yeah, so crawl distributions. I'll go back to the demo, and that's the... And so this should have worked. I'm going to go to the search service application and pray. I'm not having a good demo time. And oh, it's worked. Okay. Hey. So there we go. We've gone from 2 to 4. So we can see our high availability. We've now included 2 new servers here, SPO5 and SPO6, which we didn't have in the topology before. They're now hosting components. So we basically, you can see the distribution. On SPO3 and 4, we've got index partition 0. 5 and 4, we've got 1. 5 and 6, we've got 2. And 3 and 6, we've got 3. So we've got this spread out, highly available search infrastructure. And as I said, in real world, you might want to have a third query partition in there. So the only other thing I was going to mention was this concept of distribution. And basically with distribution rules, you can only do this if you've got 2 or more crawl databases. And 2 things happen. We add a rule. I can do something nice and simple like intranet.isc local. No, start again. London.local. Can't spell. And because I've got 2 crawl stores, it's already in the other one, I can choose to add it to this one. So basically I'm saying move it to this one here. So this URL will now only be crawled, or is dedicated effectively to being crawled by this crawl database. So all of the content in the existing crawl DB is going to be pushed over, minus the rubbish that we leave behind, and I'm dedicating it here. If I apply the changes, and OK, so you can see here it's saying based on the host distribution, no items to be moved. We can apply. In a very large infrastructure, what you would get here is a scenario where you would get a percentage count. So you'd see the host distribution rule. In fact, it's not going to move because my components didn't connect to that DB. Okay, so you're not going to see it. But what you would generally see is you would see a list of the URLs that were due to be moved. You would see what's called a refactoring count, and you would see a percentage, and it would just climb. And as the percentage is basically showing you the content being moved over and the index being refactored. And once it's complete, you're ready to go. While it's refactoring, you can't crawl. Okay, your crawls are all paused at that point. And hopefully this will finish at some point. Or maybe not. The other thing just to think about, going back to the search service application, I don't think it's going to work. Oh, come on, do me a favor. If you go into host distribution rules here, so we've got it set there, it's not applied yet, but what you can also get in here, if you have more than one crawl DB, but don't apply host distribution rules yourself, you just allow SharePoint just to distribute the URLs as it sees fit. It'll distribute them the first time on the very first crawl. They will stay connected to the same database. They're not going to flip-flop between databases during crawls. But what you can get, if you ever come and look at this page, is a nice little message across the top saying, we've detected that your search environment is unbalanced. Would you like me to rebalance it for you? And SharePoint will do this for you based on the statistics of the databases. So if you've got one heavily skewed DB with millions of items in, and one that's only got a few thousand, it will try and balance them up for you based on the URLs. So it kind of just tries to do you a favor. Personally, if it's telling you that, I always go and check to make sure that it's telling me for real. You know, if it says, we can refactor this for you, it won't tell you what it's going to do, and that's a bit of a problem. So I prefer to know what's actually happening. Go and count the amount of items I've got in my URLs myself and think about moving them. But it's sensible enough to know that you have a problem with your crawl. It might be the way you want it to work. You know, that might be what you intended. I'm going to try and apply that and see if it actually does work. It probably won't because we've no components. How are we doing for time? We're just about due to end. So that's kind of it in terms of the scale-out side of things. There's obviously a lot more to it in terms of building huge search service applications, adding additional components. There's lots more you can do, but fundamentally, those are kind of the things that we're looking to achieve here in terms of high availability for the various bits and pieces, for high availability for crawling, high availability for querying, both in terms of the components on the disk, the components in the databases, or the databases in SQL, sorry, and in terms of the query processor itself. And of all three of those pieces, the components, the processor, and the crawl engine, the query processor is the one where all your bottlenecks happen. It's the one that's going to suffer the most from bottlenecks, from slow SQL queries. So you get a bottleneck in SQL, but it's the query processor you need to look at to determine where that's happening. The query processor stats and the ULS logs will tell you exactly where it's coming from. You will see things like slow query response time in property DBX. You will see slow full text index query against component Y. And all those things will show you where the bottlenecks are in the system. You'll see slow security trimming, so it's time to boost the security trimming cache, etc.